Hey guys, we're going to take a look at the basics of velocity versus time graphs. This will basically tell us the velocity of an object at any particular instant in time. So let's start right at 0 seconds right here, where we see that the value of the velocity is 3 meters per second. So this is telling us the initial velocity. That would be the meaning of the y-intercept in this case. Now, looking at these flat sections, if you're used to dealing with position versus time graph, you may be inclined to think of this as an area of no motion. But really, on this type of graph, it is showing that there's a constant velocity, in this case a value of 3 meters per second. Now remember, velocity is a vector, and we're going to want to be careful with what the sign and the magnitude of these values mean. Remember, the sign simply refers to the direction, and the value of the velocity, the numerical value, represents the speed. So you want to avoid the trap of thinking that a negative value is somehow less than a positive value. It merely represents a different direction. We'll want to be particularly careful of that when we're considering changes in the velocity, such as this section here, where it is speeding up, as we can tell by the increased value, and it's doing that in the positive direction. In this section, the value is decreasing only up till this point, so that is slowing down, but it is still moving in the positive direction because we still have a positive value. At this point here, we cross the x-axis, and we want to be sure of what that means. We're going from a positive to a negative direction. This means the object is actually changing direction. But now, even though it's in the negative direction, the magnitude of the value is increasing. So this represents the object speeding up in the other direction. So our object was slowing down here, turned around, and started speeding up in the other direction. Now the line levels off, and that's indicating it's moving at a constant velocity in the negative direction. And now, as we go back towards the x-axis, the magnitude is decreasing, so it's slowing down, but it is still moving in the negative direction because we have a negative value. At this point, we cross the axis, indicating that the object has changed direction, is now moving in the positive direction, and the value is increasing, so it is speeding up, finally leveling off at a constant velocity in the positive direction. As with any graph, it is often useful to think about what the slope might mean. Mathematically, the slope is expressed as change of y over change of x. But we can figure out what this actually means in terms of physics by just looking at the units. What is on the y-axis, what's on the x-axis? So in this case, that is change of velocity over change of time. And what does that mean? That is, of course, acceleration. Knowing that the slope of this graph represents the acceleration, we can then look through any part of this and know what the acceleration is at that point. Where there is a slope of 0, there's 0 acceleration. Where we have a positive slope, we've got positive acceleration, and so on. An interesting place to look at is here where it's crossing the origin. Notice how we have a constant negative acceleration, and we can look at the effect that has on the velocity. Where you have a positive velocity and a negative acceleration, the object is slowing down. After we cross the axis, we still have a negative acceleration, but now the velocity is negative and the object is speeding up. Notice how across the origin, the object is changing direction, but the whole time that this is happening, slowing down, speeding up, changing direction, the acceleration is constant. Same thing is happening over here, except that is now a positive acceleration. So when we're reading these graphs, we have to be a bit more careful than with position time graphs. Position time graphs tend to be a bit more intuitive. They sort of look like the motion that is occurring. With a velocity time graph, you want to think carefully about what the sign of the velocity is and what the magnitude is. Think about what the numbers mean and don't just try to feel out what it's doing. So we've seen that the initial velocity is equal to the y-intercept. So of the things that you're commonly going to look at for a graph, the y-intercept, we know what that means. That's the initial condition, the initial velocity. The slope of a velocity time graph is equal to acceleration. One other thing that we can look at in a graph is what the area under the curve might mean. Now let's be clear, that's the area bounded by the line or curve and the x-axis. So to figure out what the area under the curve equals, it's simplest to look at the units. If we want to find the area of one particular spot, say from 0 to 5 seconds right here, we're finding the area of this box. And that would simply be the base times the height. But what are the units? In this case, we're multiplying time, which we call the base, time by velocity, which is on the vertical axis, or seconds times meters per second, and the seconds cancels out and we're left with meters. So in this case, the area under the curve is actually equal to the displacement